Hello there, this is some more work on Year 12 Discrete Maths for further maths. So on the OCR board we are in my school doing discrete maths as one of our options, and so I've already done some videos, so hopefully you'll be checking those out as well, because overall there's a lot of work here for you to be able to look at and help with your studies. So bin packing is a weird thing where we have these what are called algorithms, and algorithms, as we've already discussed, are sort of like methods that we can use to understand what the answer might be, but it can't be any old method, and they need to be done in a set method. And bin packing is basically this idea that we want to put certain numbers and use certain amounts in a way that is most productive. For instance, if I'm cutting wood and I am cutting wood for a job, I wouldn't really want to cut lots of small pieces from lots of big pieces and end up throwing away the other bits. I'd be trying to use a big piece of wood and maximize all the little bits and bobs so that I don't throw very much in the bin. I don't waste anything. And that's what this is all about. It's trying to not waste too much of our resources. So this says boxes of varying weights are placed in some bins. Literally, this is why it's called bin packing. You throw things in bins, and you post those things together. It could be like a parcel, or it could be like a piece of wood, as I said. But this example is bins. So it says boxes of varying weights. I've got a box of weight 6. I've got one of 2. I've got one of 3, and so on and so on. Each bin can fit a maximum of 7 kilograms, and we're going to try to use what's called the next fit algorithm. Now, this is one of 3 or so different algorithms that we could be asked to use, and the next fit is, as it says up here, and then there's a wordy description for each of these methods. It says involves making a pass along a list starting at the left hand end and packing each item into the next bin that has enough space for it, starting from the bin that has just been used each time. Now that's the critical thing here. This is basically says we use the next bin if we need another. Otherwise, we use the one we can. So this first 6 here, you can see 1, 2, 3, 4, 5, 6. If I start with this, I put the 6 into there, and this is all now used. It's got a little gap at the top, so if I had a 1 next, I could put it straight in there. But interestingly, my next one is a 2. Now the 2 is going to go in there, into the bin 2. And that is all now taken up. But again, I've got space here, so what have I got next? I've got a 3. And my 3, now notice I put it into the one I've just used. If not, I put it into the next bin. That 3 goes in there. Boom, 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 boom. And then I've got a 4. Now, my 4 doesn't fit in here. Notice I didn't even look at bin 1. I'm just saying it doesn't go into bin 2. Look at the next one. That's bin 4. So that's 4. Boom. And that's all gone. Next one's a 5. Oh, a bit rubbish. So 5 doesn't fit into the bin 3. So that's why I'm looking in this one. And I put a 5 in there. Then I got a 1. Well, that's lucky. There's a space for that. Oh, and then I got another one. So there's a space for that. Now, it may well be, for instance, that is the best way of doing it. You can't use any fewer than 4 bins no matter what you do. But you'll notice I ended up using 4 bins to pack all those boxes and of those weights. As I say, it may or may not be the best possible way of doing it. And what we're trying to do, I suppose, in this task is we try to minimize the number of bins used. And this is used 4 bins. It could be that I could use 3 bins, for instance, if I was really careful. It might be that this doesn't do it no matter what I do. So that's the next fit algorithm. So here's another example of the next fit algorithm. It says a carpenter is cutting wood. So I was like the one I was just describing, cutting woods from 10-meter lengths. So 10 meters is all I can cut from. He cuts what he needs. So he's got a 6 he needs. So obviously what we do, we say, well, take that from the first piece of wood. Notice I've called it bin 1, even though it's really piece of wood 1, but we very often call it still bin 1. And the next one is a 5. Well, 6 and 5 makes 11, so that's too much. So I'm going to have to go to the second piece of wood, bin 2. So that one's done, and that one's all done. Now the next one's a 1. Now I can write it like that, I suppose. It definitely comes off. Notice I didn't even look at bin 1. That's gone as far as I'm concerned. 5 and 1 is 6. Next one's a 3. 5 and 1 is 6, plus 3 makes 9, so that's still okay. What's the next one? Next one's 7. Doesn't fit in here, definitely not. So 7. Done that. And then I've got a 2. Fits in bin 3 very nicely, but there's only one space there now, so I'm going to need bin 4. Notice it's a bit rubbish, this, isn't it? I could easily have put that 4 into the bin 1, but you can imagine now that piece of wood's gone, it's forgotten about, it's somewhere else. I don't care where it is. I've just charged whoever is I'm making whatever I'm making for them in their kitchen or whatever I'm doing. I've just charged them 4 pieces of wood rather than 3. It doesn't bother me. So it's a bit of a weird one, but sometimes that's what you do. You just do what's nearest to you. So next fit algorithm needed 4 pieces of wood. Next one we're going to talk about is what's called the first fit algorithm. The first fit algorithm involves making a pass along a list, starting at the left-hand end and packing each item into the first bin that has enough space for it, starting from the first bin each time. So this is subtly different. This is more logical in many ways, assuming you've got access to all the things that you have been playing with. So a boy is putting books into boxes or bins. So this sounds very much like the first one. He has to walk from one side of the room to the other, but they're heavy, so he always puts them into the first available box or bin. He carries 3 books, then 2. So these are the numbers. The maximum number of books per box is now 8. Okay, so that's our maximum. So what's our first number? It's 3. So you can see I'm going to do this in the same way as I did last time. There's my 3. Ding, 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 ding. So all that's done. So that one's done. Then he's got a 2. Now, 2 obviously goes in here again. 3 and 2 makes 5. So that seems to work. Yep. Done. Next one's 5. Well, next one's 5. Well, he's got no space here, so but you can go quite happily. You can go and put that into bin 2. So there's 5. Let's colour that in so you know it's all gone. What's he got next? Now, his next one is a 3. Now, look, this is the difference. If this was next fit, I'd go into... No, actually, I'd go into here. But because it's first fit, I put it into here. I go back to the first bin every time if it's possible. That's gone in there then. Next one is a 1. Well, again, I obviously can't use bin 1 now, but I can go here. That's a 1. Next one's a 6. So what's that go? Well, that's obviously doesn't go in here, but I can put it into here. That's a 6. I'm just going to colour that in to show that it's been all gone. So that's that one done. I've got a 3. Now, there's no space in here. There's no space in here. And this one's a 3. So there is a bit of space there. And lastly, I've got 1 book left. Now, look, again, I go back to wherever I started from. And that means it goes in there. And potentially, the advantage of the first fit algorithm is it should be a bit more likely to produce the best results, the most efficient use of resources. So I still used 4 bins, but I've still got a quite large piece of wood there. Was it wood? No, it wasn't. It was a space in the bin. If I get some more books I need to put in, that's quite a nice big space for me to put them in. So that's the idea. And again, it needed 4 bins here. Here's an example then. It's the first fit algorithm. Again, so board 1. How long are these boards? It's a carpenter again, cutting pieces of wood. This I'm called skirting boards. They're 10 meter long, and these are my numbers. So what do? I take my 1, and you can see I'm going to put a 1 there. Tick. In fact, I just use these here, aren't they? So that's my 1. I've got a 2. Okay, that's going. I cut it from there. And then I've got a 9. Well, there's no space here now because it goes up to 10. So there's my 9. I'm going to put that in there. That's done. 4. Notice I go back to board 1. So that's my 4 in there. 1, 2, and 4. Now I've got 7 done. I've got 1. Oh, that looks good. It's going in there. Always go back to the first one if possible. So that's that one done. Well, how many have I got in here now? 1, 3, 7, 8. All right, so this new one I can put in there as well. That's 9 again. Then I've got a 3. Well, there's no space here. I'm going to have to go into board 3 for that. That's my 3. Then I've got a 5. No space, no space. Oh, I can put that in there. That's good. And then I've got a 3. There's no space, no space. All right. Now, and this is where even this sometimes lets me down, because although it's not bad, there's a huge, big piece here which I've not used. And I reckon I could probably tidy that up and get away with less boards. Note, however, I don't care really. If this was an exam question, I would put this down. I wouldn't be saying to them, but I can do it better. They don't care about that. They care, have you used the correct algorithm? Are your boards got the right numbers for each one? Ours have, so that's good. The last one of the proper algorithms is called the first fit decreasing algorithm. Now, on the first fit decreasing algorithm, you put them in order first. And this improves things still further. So look, the small ferry has 3 lanes, each 20 meters long. So now it goes up to 20. The lengths of the vehicles are in queues are as follows. Now, these are my numbers. First of all, I'm going to look at those numbers. I'm going to put them in order. So this is why it says sort. My biggest number there is 12. That's gone. What's my next biggest? It's 8. Then I reckon I got a 7 and a 6 and a couple of 5s. What else have I got? I've got no 4s, but I've got 3 3s, I think. Have I counted those right? 1, 2, 3. Yes, I have. I've got a couple of 2s and I've got a 1. So I put them in order like that. And then I apply the first fit algorithm as before. But it's called the first fit decreasing algorithm because I've already put them in order. So what's it got? I've got 20 meters long. So my first one goes in there, 12. And that was lucky. My second one's an 8. So 12 and 8 equals 20. That one's full, completely full. What's my next one? My next one's a 7. So that one's done. Then I go the 6. Well, the 6 goes in there. 7 and 6 is 13. And the 5 makes 18. So it's not full. Where am I up to? 765. Next number's a 5. So that goes into lane 3. And then, I said 7, so that's 18, that is. I reckon I'm going to get a 2 in there in a bit. But not yet. So I'll put the 5 in. Then I put a 3 in. In fact, all 3 of those 3s, I think, are going in here. What's that? 9 and 14. I've still got a bit of space. My next number's a 2. This is where this is so good. I can go back to this one. Put it in this one. 7, 6, and 5, and 2, I reckon, is now 20. I've got a 2 left. And I've got, what's this add up to? 9, 11, 16, and that equals 17. So I end up using 3 boards this time, or 3 lanes, wasn't it? It was the lengths of vehicles on a ferry. Okay, so that was 3. Now, the final one is what we would call an ad hoc method. Now, this is an ad hoc method is a posh way of saying you just kind of work it out for yourself. You just do your best and see if you can work it. So that, it wants me to do 3. I don't think I'm going to get time to do all 3 methods, but I can show you a full bin method. So the full bin method then involves trying to fill them to full capacity. And then make bins that are as full as possible. So what have I got? They must at most hold 10. So I've got these numbers. Well, straight away I look at this and I go, I've got a 2 and an 8 makes 10. So that's that one done and that one done. I've got a 6 and a 4. And you just try to fill bins or boxes, or whatever it is, 6 and 4. And that's lucky. I've got a 2, a 5, and a 3, a 5, and a 2 left over, and they happen to magically add up to 10. Now, the problem with these ad hoc methods is sometimes you've got a million numbers. It would be really complicated. But cracky, with only this minimal number of numbers, you can see that's a relatively easy method. But notice the others you expect you to do it in a set order. This just expects you to get a good result. And that's it. So I'll just show you that what we are going to do in class, perhaps. So, but a few things to note. The first fit decreasing bin packing algorithm is generally more efficient. So that's what I said is the best one. They're not always guaranteed to give the best solution. There's no definite one that will give you the best solution. And whenever an algorithm is not guaranteed to give you the best possible one, it's called a heuristic algorithm. So just look out for that words. Best of luck on algorithms and bin packing.